First, let me introduce my team. We are a team from the Department of Environmental Engineering at Gwangwon University. There are 5 of us: Hyosun, Hyewon, Seunghyun, Sanguk, and Eunbi. So I'm going to get down to business now. Do you know about photocatalysis that remove organic matter from contaminated water? Photocatalysis are substances that can decompose organic pollutants according to these reactions when they receive UV light. In this reaction, if UV light or photocatalysis do not meet contaminated water, the reaction does not occur. So, in order to effectively remove organic matter, contact between these 3 elements must be smooth at the same time. If so, how can we make better contact between these elements in the reaction? Our research begins with this curiosity. As a result, the name of the filter we made is OURglass. This reactor can be fitted with a UV light source in the middle of the cylindrical reactor and a photocatalytic filter made of a curved surface. It also enables continuous reactions. The light source in the middle will be able to shine evenly on the contaminated water. And the shape of this filter doesn't look like an hourglass. The filter is named after this shape. This hourglass shape creates an eddy current of vertical water so that make it blend better. And it caught more photocatalysis than just cylindrical filters.
Let me introduce about the changes of our filter's design. This is our first design of our filter. At first, I attempt to experiment with changes in the shape of the holes within the filter, rather than altering the form of the filter itself. Our new design introduced a variation in the shape of the filter rather than the shape of the filter holes. Below are diagrams of a cylindrical filter and a curved filter resembling an hourglass. The concept of the curved filter is inspired by considering the flow of water, such as water currents, as discussed in the previous idea introduction. This aims to enhance the efficiency of the reaction with the photocatalyst for a more effective water purification process. These are our 3D printer diagrams for filters and the reactor, which are perfectly fitting for a laboratory water pump.
Well, then we checked how many coatings are best suited through a batch test. We made 4 filters for batches that are 25% size of the original filter. After that, the experiment was conducted after coating for filters 1, 3, 5, and 10 times respectively. By comparing the treatment capacity of 1 ppm methylene blue solution, it is an experiment to confirm the appropriate number of coatings of the original size filter to be used in this experiment. The coating was repeated in the order of TiO2 solution application, natural drying, oven drying. Since the absolute value of the trend line was the largest in 3 and 5 coatings, the number of coating of this experimental filter was determined to be 3 and 5.
After setting the number of coatings through a batch test, we conducted a methylene blue reduction test by using OURglass. The experimental setup is like this. First, we put OURglass into a reactor, which is printed using a 3D printer, and then place a UV lamp inside it. Then, we connected a pump to the reactor to circulate the methylene blue solution during the lessons time. At this time, the flow rate of the reactor was 51 milliliters per minute. The initial concentration of methylene blue was set at 1 ppm and total reaction time was 75 minutes. Sampling was performed every 15 minutes to measure the absorbance of methylene blue. Samples extracted at each time were analyzed with UV visible spectrophotometer to determine the reduction concentration and efficiency.
To sum up, we made a flow reactor filter for purifying water and its name is OURglass because it looks like an hourglass. We performed 2 tasks. The first experiment was to determine the number of cutting on the filter. And the second one was to check the difference in performance between the straight filter and the curved filter. The first experiment was conducted with a quarter-size filter and showed us the number of cutting for the second experiment was determined 3 times and 5 times. The second experiment was conducted with a continuous flow reactor, and the curved filter was more effective in purifying contaminated water regardless of the number of cutting. In conclusion, we confirmed through experiments that the purification effect did not increase as the number of cutting increased, and the curved filter performed better than the straight type. I would like to thank Professor for leading the capstone design and the lab doctor and graduate student who helped in the experiment. Thank you for watching the video. Bye!